Welcome back to my channel. This is the question number 4 from Excel International Advanced Level, January 2021, paper 2. This question is on binomial expansion, chapter 4 from Pure Mathematics 2. The question states, find the first three terms in ascending powers of x of the binomial expansion of the given number 2 plus p into x to the power of 6, where p is a constant. Give each term in its simplest form. Here what we are going to do is we are going to use the formula of binomial expansion. I have already written the binomial expansion formula over here. This is the formula you are going to use. Now in the question they have given clearly that you have to write the first three terms in ascending powers of x. So the first power of x is going to be x to the power of 0 and x to the power of 1 and then x to the power of 2. These are the first three terms starting from 0 till power of 2. Now if we look at this formula, this is going to be written as 2 plus 3x to the power of 6. Now looking at the two given things, a plus b raised to n and 2 plus px raised to 6, we can compare and say that a is equal to 2, b is equal to px and n is equal to 6. So let us start expanding 2 plus px raised to 6 using this formula. So 2 plus px to the power of 6 is equal to, our first term is a to the power of n. We have a here as 2 to the power of 6 plus ncr. This n1 is nothing but ncr. So we are going to put it as 6 and 1 over here because our n is 6 and it starts with 1. Then a to the power of n minus 1. So a is 2 to the power of 6 minus 1. b is px. So we are going to write px here plus nc2. So n is 6. We have 2. Then we are going to write a to the power of n minus 2. A is 2. N is 6 minus 2. B to the power of 2. Px to the power of 2. We have to stop over here because as we have seen, the first three terms in the ascending powers of x stops at x square. As you can see here, our x is raised to the power of 2. So we need to stop expanding it over here. Now they want us to solve this given statement which we have got. So 2 raised to 6 is 64 plus. To solve 6c1, what we are going to do is, as I will show you here, let me just reduce this one. So we are going to put it this way in the calculator. 6 and shift, click on this C and R is 1. So click on 1 equal to, get it as 6. So we write 6c1 as 6 as we have got it. 2 to the power of 5. So 6 minus 1 is 5. So 2 raised to 5 is 32 into px. Because this is raised to the power of 1 plus, to get 6c2 we do the same thing, we write 6 and shift and c into and say equal, we get it as 15. So we are going to write it as 15. 2 raised to 4 because 6 minus 2 is 4. So 2 raised to 4 gives you 16 p square x square. Remember to distribute the power to p as well as x. So further simplifying this, we get it as 64 plus 6 times 32. So we are going to do it here. 6 times 52 gives us 192. So 192 x plus 15 times 60. 15 times 60 equals 240. 240 p square x square. This is the answer for our part A. Okay, now let us see what is the B part of this question. Given that in the expansion of this bracket and this bracket, the coefficient of x square is minus 3 by 4. Find the possible values of p. So the question is asking us to expand these two terms, and whatever x square terms we get after the expansion of these two brackets, we have to equate it equal to minus 3 by 4. So 2 plus px to the power of 6, we have already got it as, okay, this is what we got from part A. So we have to multiply 3 minus half x with this given 2 plus px to the power of 6. So let us start doing it. So 3 minus half x should be multiplied with 64 plus 192 px plus 240 p square x square. Now the trick over here is do not multiply 3 with all the terms. You need to multiply it with the terms which will give you a coefficient of x square. Now for example, if you multiply 3 with 64, you will not get an x square term. So no need to multiply these two. 3 with 192 px, again you can see you will not get x square when you multiply it. But when I multiply 3 with 240 p square x square, you can see I will get a x square coefficient. So p into 240 p square x square. Similarly, if I multiply half x with 64, I will not get an x square term. But if I multiply half x with 192 px, I will be getting an x square term. So I can multiply this with this. That gives me minus half x into 192 px. Again, if I multiply half x with 240 p square x square, I will get an x cube term. We will not get an x square term. Hence, no need to multiply minus half x with 240 p square x square. Now let me simplify this. This will be equal to, so 3 into 240. So let us see, 3 into 240 gives us 720. 720 p square x square, then minus half into 192. So it is nothing but we have to just divide 192 by 2. That will give us 96. So it becomes 96 p x square. As you can see, we have got x square terms. Now we have to equate it equal to the coefficient of x square is minus 3 over 4. So it becomes minus 3 over 4 x square. We equate it this way. Now, as you can see, x square term is common on both the sides. So we can just simply strike off the x square. There we go. And you are left with 720 p square minus 96p is equal to minus 3 over 2. Now I will multiply on both the sides 4. So that gives me, I'm multiplying the entire bracket with 4 over here. Here I'm multiplying with 4. So we will see 4 times 720 gives us 2880 t squared minus 96 into 4 gives us 384 t is equal to minus 3. As we can see, the numbers are quite high. So what we can do is we can divide all these sides by 3. Let's check if they are divisible by 3. So starting with 2880 divided by 3 gives you 960. This is divisible. This square minus 384 divided by 3. So yes, 128 and 3 divided by 3 is minus 1. So we can form a quadratic equation after this. 960 t squared minus 128 t plus 1 is equal to 0. So to solve this equation, you can use the quadratic formula, that is t is equal to minus 3 plus minus root of square minus 4ac divided by 2. So here we have a is equal to 960, b is equal to minus 128, take it along with the sign, and c is equal to plus 1. Now substituting over here, minus of minus 128 plus minus root of minus 128 of whole square minus 4 into 960 into 1 whole divided by 4 into 960. So let us solve this now. So minus of minus 128 becomes plus 128 plus minus. Now let us see what is the square root of this entire term. So we take it as square root of, put a bracket, minus 128 square minus, put a bracket again, 4 into 960 into 1. Let us see what we get. We get it as 112 over 2 multiplied with 960. That gives us 1920. So this gives us two values of t, as you can see. We get it as 128 plus 112 over 1920. And another value is 128 with minus 112 over 1920. So let us see what we get for the first one. We put here as 128 plus 112 divided by 1920. We get it as 1 over 8. Now let us look at for the second value, what we get. So it is 128 minus 112 divided by 1920. So we get it as 1 over 120. So these are the two values of t. So once you find this is the end of part B. These are the two values of